This presentation examines droop, flow curves, setting the outlet pressure, and the supply pressure effect on gas regulators. Droop is the reduction of outlet pressure with flow. In this example, an AP1000's inlet pressure is set to 100 psi. The regulator is opened and adjusted to 30 psi outlet pressure with no flow. As flow begins, the outlet pressure drops. At 10 liters per minute, the outlet pressure droops to 28 psi. As flow increases to 15 liters per minute, the outlet pressure drops to 26 psi. And at 30 liters per minute, the outlet pressure further drops to 23.5 psi. This reduction in outlet pressure with higher flow is called droop. Regulator droop is caused by several factors. A larger orifice, diaphragm, and diaphragm stroke reduce droop. The adjustment range spring's force decreases with spring extension as the diaphragm moves downward. This increases droop. When a regulator transitions from low flow to no flow, the regulator creeps or locks up, and the outlet pressure increases slightly above set point, increasing droop. Finally, higher supply pressures decrease droop, and lower supply pressures increase droop, as we will demonstrate in the next slide. This is a typical droop curve or flow curve. At the top, it indicates the gas used, in this case, nitrogen. Flow curves plot outlet pressure on the vertical x-axis and flow on the horizontal y-axis. The bottom left of the chart is zero flow and zero pressure. This AP1500 regulator flow curve demonstrates the impact of 4 different inlet pressures with a 20 psi fixed zero flow outlet pressure setting. You can see the significant impact of inlet pressure on regulator droop. As inlet pressure decreases, droop increases. When sizing a source regulator for gases, it is generally advised to use a flow curve with the intended cylinder change pressure for the inlet pressure. Using an inlet pressure of 200 to 300 psi, for example, as opposed to full cylinder pressure, will allow the user to select the correct regulator. This graph shows the impact of low outlet pressures on the AP1000 and 1300 series regulators. You can see that the slope of the droop with 20 psi and 10 psi outlet pressures are similar. Shifting the outlet pressure up or down does not alter the flow curve slope. However, below 10 psi, the slope is much steeper and flow capacity is greatly reduced. The AP Tech 208 guide, our guide of recommended valves and regulators for specific specialty gases and flows, is available online at AP Tech's website. For distribution regulator applications downstream of the source regulator, the 208 guide recommendations are based on a 30 psi inlet pressure for gases and at least 10 psi outlet pressure. This is due to the large impact of low outlet pressure on flow capacity. Below 10 psi outlet pressure, flow capacity is greatly reduced. Now we'll demonstrate 2 methods to set the outlet pressure. The most common method is static pressure setting. This means setting the pressure regulator with no flow. As flow begins, outlet pressure drops compared to the set point. This is due to droop. When flow stops, the outlet pressure will rise slightly above set point due to creep or lockup. This is normal and will be explained in detail in later training. Dynamic pressure setting means to set the outlet pressure with flow. This allows for a more precise pressure at a given flow. In this example, the regulator is set with a fixed flow downstream. When flow stops, the outlet pressure rises above the adjusted set point due to droop. If the flow rate changes later, the outlet pressure will vary. Supply pressure effect is a change in outlet pressure as a function of supply pressure change. This effect is usually specified as the change in outlet pressure per change in inlet pressure. For example, 0.25 psi change in outlet pressure per 100 psi change in inlet pressure. Normally, supply pressure effect is encountered when the inlet pressure decreases as gas cylinders are consumed. As a result, outlet pressure increases as a gas cylinder is consumed. However, the supply pressure effect works with both decreasing and increasing inlet pressure. An increase in inlet pressure will cause a decrease in outlet pressure at the same rate as specified. Now let's look at the supply pressure effect with an AP1200 regulator. In this example, the inlet pressure is 2,200 psi. The outlet pressure is 88 psi. As the inlet pressure drops to 200 psi, the pressure when cylinders are often changed, the outlet pressure continues to rise. The 2,000 psi drop in inlet pressure causes a 70 psi increase in outlet pressure. The AP1200 supply pressure effect is 3.5 psi per 100 psi change in inlet pressure. Higher flow regulators generally have greater supply pressure effect than lower flow regulators. Now we will demonstrate the supply pressure effect on the AP1900. Again, the inlet pressure is 2,200 psi. Outlet pressure is 81 psi. The 2,000 psi drop in inlet pressure only causes a 5 psi increase in outlet pressure. The AP1900 supply pressure effect is only 0.25 psi per 100 psi inlet pressure change. Lower flow regulators generally have less supply pressure effect than higher flow regulators. In order to understand the causes of supply pressure effect, we will introduce the force balance equation. The downward force of the range adjustment spring is countered by the upward forces of the outlet gas pressure and the inlet gas pressure. As the gas cylinder is consumed from 2,200 psi to 200 psi, force C decreases. For the sum of forces to be balanced, force B needs to increase as force C is decreased due to lower pressure. The supply pressure effect is determined by the ratio of diaphragm area to orifice area. Higher flow regulators generally have a lower ratio of diaphragm area to orifice area and therefore generally have higher supply pressure effect than lower flow regulators. Now let's review the key information about droop, flow curves, setting outlet pressure, and the supply pressure effect in gas regulators. Droop is the reduction of outlet pressure with increased flow. Static pressure setting is setting the pressure without flow. Dynamic pressure setting is setting the pressure with flow. This method is more precise because it compensates for droop. Supply pressure effect is outlet pressure change due to a change in inlet pressure, usually specified as outlet pressure change per 100 psi inlet pressure change. High flow regulators generally have more supply pressure effect than low flow regulators. For more information about APTech products and technical resources, please go to aptech-online.com, where you can download our 208 guide, the Pressure Regulator and Valve Selection Guide for most specialty gases used in semiconductor manufacturing.